Okay, so this is an unusual presentation because I can kind of begin with the normal ending slide of a presentation, which is the Q&A, and people say if you've got any questions, and kind of like usually, you know, you've got like 2 minutes and there's no time to really ask anything, and the presenter doesn't know what's coming, so, you know, Q&A sessions are okay, but they don't go very well sometimes. So on the previous two presentations, there were in particular a couple of questions which really stood out for me as being questions that, one, they kind of get to the root of how you use OEM performance pages effectively, and two, they're the kind of questions that I'm asked in the office all the time. So over the past several years, I've helped a lot of people learn to use the OEM performance pages, and there's a few questions which keep cropping up. And one of those in particular cropped up during one of the first session in this case, and it kind of occurred to me that it'd be worth digging into it a bit more deeply, because this is a kind of monitoring technology which I've talked about for a couple of days at a time when I was doing courses for Oracle. So I wanted to dig into a few things a bit more deeply. I should apologize in advance for my Barry White voice. In this particular case, it's not because I've got a massive hangover, it's just because I've just got back from the US. So there's a bit of jet lag and lack of sleep kicking in. So hopefully you can bear with both the accent and the deep tone of my voice today. So the nice thing as well is, let's just kind of deal with, hold on a second, let me just fix something here. So, yeah, wrong one, this one. Okay, so here's a small list of the kind of questions I wanted to dig into a bit more deeply. And they're kind of quite wide questions because, as I say, they go to the core of how you use the OEM performance pages. And I think it's very easy to be misled by some of the stuff you see. Also, some of the questions are about, come from my experience of using them. So they're the kind of problems I've seen when you use them. The initial experience of OEM performance pages is kind of like dazzling and wow, right? But the real benefit you get from them is when you really start to understand them, and when you really start to understand Oracle performance, to be honest with you. And I've said frequently to people that although the OEM performance pages make performance analysis a lot easier for people who haven't done a lot of performance analysis, they're really effective when you actually understand a lot about Oracle performance. So hopefully I'll be able to drill into some of the slightly more complex details here. So just running through them very quickly, and I may not come back to this slide, but this is roughly what the format will be. This first question might not have been directly a question that was asked at the end of the first session because I was doing it from memory, but it was pretty close, right? It's like, how do I differentiate when I'm looking at these graphs between what's important and what isn't? So that's the first thing we'll look at. Another one that gets asked all the time, and I've been asked this frequently over the years, and was literally asked this about 1 or 2 weeks ago by an old friend. How can I be consuming more CPU on this graph than the CPU in the server, right, in the system? So that's a really common question which I wanted to drill into. And another one that's come up quite often is, how can I tell whether something has actually improved system performance in any way? It's like I've got some pretty pictures, but I don't really know whether things are better. Okay, so we'll talk about that. And then I've got a few different cases about how I think one of the things about OEM performance pages, which is super effective at, especially if you're experienced, is that it helps you to understand or remind you how Oracle actually works and how does it evolve over time. So there's quite a few problems where in the past, I'm not sure I would have got to the root of the problem so quickly because it was quite technical. But when you see it displayed visually, it kind of makes the problem much more obvious. So hopefully I can get through a couple of examples of that kind of thing. So to crack on with the first question, how do I differentiate between what's important and what isn't? I'll just drop into the VM here. Now, if we look at the top activity page now for the past hour, we can see that, yeah, there's kind of activity going on all over the place, right? There's constant activity going on within Oracle. And there was there was a burst of activity over here, which for anybody who follows me on Twitter would know that I was actually having to rebuild something, right? But this kind of looks really busy, this period of activity, right? And in fact, even if I go over to here to a more recent period, there's stuff here which looks really interesting, which I should really dig into and investigate, right? Because I've got a bunch of sessions here and a bunch of SQL statements, and I should really kind of go and try and analyze them. So what I'm going to do is I'm going to kick off a quick benchmark using Swing Bench as I did before. And this is going to be a 4-user benchmark, which I'm just going to run for a couple of minutes. Okay, so we've got 4 users here, there's no think time, and I'm just going to run it for 2 minutes. Now, if I go back and look at the top activity page, it kind of refreshes, and things may run a little bit slow because my laptop's hot, I'm jet lagged, I'm running benchmarks. Okay, but we'll start to see some activity appearing shortly. I'll give that a minute. And the graph will start to change, right? So I can see that I've now got these 1, 2, 3, 4 sales order entry sessions, which is what Swing Bench uses to connect to run this benchmark. And if I switch back to the 15-second refresh, we'll see that the graph's going to have changed quite a lot. So now I have this enormous spike, okay? So here I have an utterly quiet system. Here I have a system where I was rebuilding the schema. And here I now have this benchmark running, although it's safe to say that it's only 4 users, but it looks pretty busy now, right? So now I'm starting to see more activity, some CPU, some user I/O, what others? We've got some commit wait class there and some system I/O. So because, and I know this frustrates long-term users, but because OEM, and this is the important part, is resizing this y-axis, right? All of a sudden, this period of activity, which looked really important before, now looks less important. And this stuff looks absolutely minuscule, which in reality is what it was. It was like, this is just Oracle ticking over in the background. This is just some background processes doing the thing, right? So if I highlight one of those really quiet periods of activity, you can see that most of it will be things like log writer, AWR, M1 slave process, the job queue process, that kind of thing. Okay, so it's really difficult to tell if you just look at some pretty pictures and look at some colors. I could have said this was busy because if the scale had been changed, if I hadn't run this thing on the right-hand side, which I've just started running, then these peaks would have looked really busy, right? So one of the things that you have to do is you need to understand what's important and what's not. Okay. So there's a few really significant factors at play here which you need to be able to use. One is, and I talked about it a few times in the presentation and kept banging on about it, but this active sessions Y graph is incredibly important. Okay, it's incredibly important because remember that what this is showing you is the average active sessions over the period of time that you're looking at. And if you can flip average active sessions around and describe it in terms of DB time, but what it's showing you is an overall system-wide level of activity in terms of number of sessions. So another way of thinking about this, and I think I mentioned this in the first presentation, is it's a little like the run queue on a Unix box, right? It's like how many processes are doing something and are actually trying to do something. So you always really, really need to focus on this active sessions y-axis. And over time, and with experience, and most of all with knowledge of your own system, you understand what's a sensible level of active sessions for your system. And in fact, one of the features that Oracle introduced, adaptive thresholds, actually looks at this average active sessions over time. And instead of saying, whoa, so for example, if I'm in this area now, right, we're kind of like, I don't know, something like, on active average, there's something like 0.25 sessions, okay? If I compared this to the 0.25, then it could look really busy because there's about 1 session active on average because there's 1 session rebuilding the schema. But in the context of a system which actually ran this workload, so when I've run the 4-user benchmark, then this other stuff, really, it's kind of Mickey Mouse, right? And bear in mind all the time that I'm talking about system-wide. So adaptive thresholds were designed to kind of look at this situation, and if we see the sudden spike, which is what we're looking at now, then it's maybe something of interest. So it's really important you focus on the active sessions y-axis and the size of it, and it's resized as the activity changes. And it's really important that you understand what's going on relative to a system which hopefully you know fairly well already, right? However, one of the good things about OEM, if you're DBA working at a site with, I don't know, 2,000 databases, something like that, is you might not always have that system knowledge. So it's great when you only deal with a few systems and you know them intimately, because, and many people have had this experience already with you using OEM, right? You can kind of go in here and go, man, that looks wrong. I kind of know my system really well, and I shouldn't be seeing that kind of thing going on, right? But if you don't know a system well, how do you know whether kind of this is normal or not? Well, one thing is to take a step back and remember that the top activity page is just kind of giving you a kind of neat system-wide overview. It would be like trying to diagnose performance of a Java or C application running on an app server just by looking at the run queue, right? It's kind of like, well, you could see that the system's busy, but it doesn't really tell you about the individual performance of your application. However, the thing to remember is the top activity page. This is a kind of nice visualization of kind of, is there some big stuff going on at the moment? And the other thing to remember is kind of what weight classes am I waiting on and how much of this is CPU and I/O and that kind of thing. But because the top activity page is based on ASH data, you can always drill down, right? So you can become too obsessed with this graph, particularly when you've got guys like me who come along and do presentations on it, right? But ultimately, you can always go down and say, for an individual user, what's actually going on with that session? Because the individual user's experience is what they experience as performance, right? They don't take a system-wide view. What they care about is how long's my particular activity taken, and we can drill into their session. By the way, the reason some of this stuff isn't refreshing is because my laptop sounds like it's an aircraft taking off. It's seriously overheated because I've obviously been doing quite a lot of work on it. In fact, I bet you one of the things I was going to raise in here from experience of OEM. What's refresh problems? It's annoying, but I'm talking about a really overloaded laptop here. Is I find myself when I'm showing people stuff that I flip between the manual refresh and the real-time refresh, right? Because the manual refresh isn't constantly trying to go and acquire data. So hopefully you notice as I switch to manual refresh, these image refresh problems became less of a problem. And I'll then maybe switch back to the 15-second refresh once the data's caught up. So for this particular session, I can see is this session a problem. I can see what it's doing. I can see what it's waiting on. I can see which is the most important SQL statement. So at the high level, to back up just a little bit, how can I know whether this thing is significant or not, this period of time over here? Well, there's a few ways. One is, if I look at it, it's kind of like, come on, it's 0.025 of an active session on a modern database. It's like, this is kind of no work. And the thing is, when you have a system or monitoring tool which is going to show you the top anything, the most important anything right now, then the most important anything during this quiet period, it's just some background processes doing the thing, right? So you can't become too obsessed with this. I'd like to rewind a little bit though, and remember, before I ran this thing here, sorry, I should probably stop refreshing it, but before I ran this thing here, this activity looked much more significant than it does now because the y-axis changed. So really, you really need to focus on what the y-axis is telling you, not just on the pretty graphs up here. Okay. Another thing, and this is a tip I got from a guy at Oracle called John Berezniewicz, whose name I can pronounce properly, otherwise known as JB, who I mentioned in the blog. When I was doing this presentation at OpenWorld once, he said, people tend to forget that these numbers here are extremely important, this total sample count, okay? Because what the top activity page is showing you is ASH data sampled over a 5-minute window and aggregated, okay? So within this 5-minute window that I'm looking at now, there are 391 samples across the system with various SQL IDs, which it's analyzing. Session IDs are higher because they don't necessarily have a particular SQL ID associated with them. But so here we've got a sample count of 527 samples over that period, right, for the busy period. If I move this over to the really quiet period again, and we look at the total sample count again, you'll see that it's 22. So you have to ask yourself, and again, it's reinforcing the idea that ASH is sample data. You have to ask yourself how important performance analysis of 22 samples over a 5-minute period is. Okay. So looking at the clock, I'll maybe move on to the next question, okay? Which is, oh, actually, before I do that, let me do one more thing. Okay, one more thing. Let me open a terminal here. Yeah, let me get another test running for you here. So what I'm going to do now is I'm going to run an old parallel execution test from papers which I did quite a few years ago, which I was using in I was using in the E4 conference this week, and it's what made me think of to try and use this. So what that's going to do is it's going to run off, we're going to go off and it's going to run, let me see, what did I run again? Let me have a look. It's going to run 4 parallel queries with a degree of parallelism of 2. Okay. So if I go back to here again, the system's now going to get a bit busier, so I apologize in advance for any kind of refresh problems or delays or that kind of thing, because I'm running quite a few parallel queries on this system, right? But it looks like it might just about survive. Okay, so just to reinforce the other point, remember when this area of activity looked important, this one more important, and this, it's getting quieter and quieter because now I'm running even more workload. So you really need to look at top activity page in terms of the workload you used on your system and that y-axis, like what's sensible. Because frankly, to give you an example, sometimes you'll see maybe library cache problems, and you'll see the number of average active sessions spike up to like 100, 150, something ridiculous like that. Frankly, if you think you're going to have 100, 150 active sessions on most modern servers doing something sensible, then you're not. Most of them are going to be waiting. So think of this graph here as kind of like a run queue indicator, a high-level thing. More than that. No more than that. Okay, so the next question I wanted to move on to was, bear with me, was how can I be consuming more CPU than is available? Okay, so if we look at this top activity page here now, and we look particularly at the CPU stuff, just let that refresh for a second. That's the problem with kind of doing performance demos, is the danger of occasionally overloading your machine, for which I have to apologize. I'm hoping my microphone can pick up the sound of the fan on my laptop, which is going crazy. I need a new laptop. Okay, so if we go and look in particular CPU plus CPU right here in top activity, so all the time we can drill down into different weight classes, right, and see how much activity is associated with that weight class. Although in CPU, for example, it's not so much a weight class as it's about CPU consumption. But I can drill into just which sessions and which SQL statements are consuming CPU. Now, one of the things you'll see in the top activity page is that there's a line which tells you how many CPU cores you have, and there's also a line these days which tells you how many CPU threads you have. But what you'll see is that the green area, which tells you how many sessions are actively trying to consume CPU. I've got 1 CPU core on here, right? I can tell you now I've also got 4 threads, but this thing is up to like 6 or 7, right? It's kind of insane. It's like I can't possibly be using that much CPU because I don't have that much CPU available on the laptop. I only have 4 threads in this VM. Okay. Now, fortunately, Oracle have kind of fixed this. In very early versions of the top activity page, this green area was called CPU, but it's now called CPU plus CPU weight because it reflects the fact that a classic problem in Oracle instrumentation is that Oracle itself is a user space program, right? So it has no real way of knowing that it's stuck in the run queue. So if Oracle starts waiting on a specific event, it says, okay, I'm waiting on this event. It goes off to the operating system. It's going to actually perform the work required to complete that event. It's going to come back and tell Oracle you're ready to run again. But the problem is that Oracle itself, your process, is stuck in the run queue. So in order to record the end time of the event, you need to be on a CPU, but you can't get on one because the system's overloaded. Okay, so this is a kind of well-known performance analysis instrumentation problem in the Oracle field. And for example, in Carey Millsap's Optimizing Oracle Performance book, which I'm sure lots of you have read, he talks about this as a reason why you'll have apparently lost time in trace files. Okay. But there's a few helpful indications which can help you understand this is going on. One is, and I'm really glad Oracle did this, they changed this to CPU plus CPU wait. Okay. So it's not saying that there's 6 sessions trying actually consuming CPU. It's saying that the 6 sessions trying to consume CPU or consuming it at the moment. However, I wrote a blog post about this a while back in the old 10G time frame. So let's go and have a quick look at that. So this is the kind of thing I'm talking about, where you would see in the top activity page, this is an 8-user SOE benchmark, I think it was, I run, and we could see roughly 8 users trying to consume CPU and a little bit of configuration stuff, concurrency stuff going on there. One thing to reinforce from an earlier presentation is, why is this only 7 when I'm running 8 users and they're hammering the system? And that's because what OEM is showing you is database activity. And because SOE is running through a JVM and is an application, some of the time it's actually running on the application level. It's not doing stuff in the database. So you'll see a slightly lower number because some of the activity is not inside the database. So you would see this 7 average active sessions here. But if you looked at the performance page, you would only see like something like 1.9. Now, in this case, it was I had a dual-core laptop when I was running this. Okay, so you tend to see several signs which can help you identify which is going on. If I go and look at this page here, this is the performance homepage. And on the performance homepage, I mentioned this briefly, but maybe not that much in the past, in the previous sessions, is you can see that the CPU used on this page doesn't go above more than about half a session, right? Because the way that this CPU is measured is different to the way that top activity measures it, and it's actually using CPU consumption here. Some of this stuff is new stuff. So now we have the CPU wait class on the performance page, and we can see that most of our apparent CPU, if we looked at it on the top activity page, when we look at the performance page, we can see that really most of it's CPU wait. Okay. Yeah. Another point I really wanted to make on this was this here. This graph up here is showing you runnable processes. So this is kind of a run queue graph. So this is looking at, actually let me switch on that CPU threads there as well. Hold on. So you can see the 4 CPU threads here as well. And you could see on here the scale hadn't changed so much from some stuff I did earlier. But we can always kind of look at the operating system run queue information here. And the fact that this load average is way above the number of CPUs and the number of CPU threads I've got is another indication that fundamentally your CPU is overloaded, right? Oh, sorry, you've consumed all your CPU resources. So you've got basically processes which are stuck in a run queue, and down here this is reflected in the fact that now this average active sessions graph on the performance page shows CPU wait. In the old days, if you were to look at the blog post, the average active sessions page showed this category here, CPU, but didn't show the CPU wait. So you would get a discrepancy between the performance page, which was showing like half a session, and the other page, which was showing 4 or 5 sessions. Final thing I want to mention on this is that when you have an overloaded system, and I've worked on a few overloaded systems, so I've seen it when I'm running benchmarks, obviously. It's not difficult to overload CPU on my laptop. But I've also seen it on a number of systems with clients and that kind of thing. It's important to understand, if you think back to the instrumentation problem I was talking about earlier, Oracle can't record wait end times effectively if it can't actually run on a CPU. So when you have an overloaded system where you've consumed all the CPU resources, not only will you see strange CPU results, lots of CPU wait here, and lots of apparent CPU consumption over here, but all your other wait times will be inflated as well. So I'm not sure whether I'm going to be able to show you this given the way I've done it. Let me see if this works out. But essentially, any other wait times will be inflated as well. So when I look at this period when basically I'm overloading the CPUs, if I was to look at other wait categories, so for example, concurrency, let me pick a weird one. No, let me pick concurrency. That's probably a good one. If I pick concurrency, all of a sudden, when you have overloaded CPU, you start to see more stuff in OEM performance pages around latching and mutexes, bizarre GC events and rack systems and that kind of thing. Because fundamentally, the issue you've got is that Oracle processes can't run effectively. So what are normally kind of microscopic events, which you wouldn't expect to see pop up in ASH too often because it's sampled at 1-second intervals, all of a sudden they become an issue. So when you see the CPU overconsumption problem and you start to see strangeness there, you should also be very aware that the stuff you see about other events are kind of impacted by that as well. So again, I'm stealing a phrase from a friend. It's kind of like, once you've overloaded CPU, all your wait times are going to be inflated. Right? So hopefully one day when you see a system like that, you'll kind of understand what's going on. Okay, let's have a look at the next one. Sorry, my mistake. Damn it. Let me go back to the slides for a moment and see where we go next. Okay, this one. How can I tell whether something has actually improved performance at all? Okay. Because, let me show you this example here. Okay. So what I'm going to do is I'm going to run another swing bench benchmark here. And what I'll do is I'll run it the same thing for 2 minutes. In fact, actually, you know what? I won't run this again. I've already run it. And because I'm using OEM and it's based on ASH data, if I just go back to the top activity page, hopefully I should still have the run from earlier. I will do because it's within a reasonable time frame. So I've got this period over here. When I ran that benchmark, and I ran it for 2 minutes, 4 users, and no think time. Now what I'm going to do is, and it's a trick that I've used in earlier presentations, which you may well have seen, is, actually let me tell you where I'm coming from on this. If we look at what the workload is here, the significant parts of it are there's some CPU consumption, there's, sorry, let me do it this way, CPU plus CPU wait, there's some user I/O, some system I/O, and there's this commit class here. And commit class, just to drill into that, is essentially limited to the one wait event, which is log file sync. Okay, so this is basically, we're waiting for commits to complete so the log file information is written to the redo log files, the online redo log files. So I can see for that particular period of time that the commit class was a significant part of the workload. What we're talking, maybe 25%, something like that. Sorry, so, not the workload, the time consumption, okay, the activity profile. So a trick I've used in the past, and I said last time that or the time before, I'm not going to recommend you do this on any production systems. It's just a funny trick that you can use when you're doing some benchmarks, is I'm going to change the behavior of the log writer. So instead of needing to writing stuff immediately to the log files and waiting for the confirmation that the write was successful, I'm just going to say, you know what, just send the write and I don't care whether it's written successfully or not. Now clearly there's big implications of that for your production system, but it's useful when I'm showing you kind of a benchmark, sorry, not a benchmark, a demonstration here. So now what I'm going to do is I'm going to run the same benchmark as I ran previously, but I'm going to run it with essentially with asynchronous commits, so asynchronous log writes. So what will happen is I'm going to run it for 2 minutes again. We should ultimately see similar kinds of activity coming along, and we'll see where we go with that. Actually, maybe I'll just see if there's any questions while we're waiting for that to do its thing. I'm not seeing everybody's stuff. Okay, that's fine. Okay, so remember the thing I was saying about the refresh? What I'll probably try here is, it is refreshing, but it's slow, and I'm not sure it's catching up. So I'm going to switch to manual refresh. Now bear in mind, this is because I've got an overloaded system. You shouldn't have to do this constantly in your workplace. It's just a small tip that if it feels to you like the kind of refresh isn't happening properly, then sometimes it kind of helps to switch to manual and then back to the 15-second. It's actually become a natural kind of act for me, and I thought it was a useful tip to hand on from somebody who's used this stuff quite a lot. Okay, so we can see that the orange stuff's gone away, right? Remember I shared that acronym with you that somebody had come up with, which was click on the big stuff. So what I'm trying to do here is, in the first run, the commit class was part of the activity. I'm trying to omit that activity by switching to asynchronous commits, which clearly over here I've successfully done, right? But there's a bit of a problem with this in that when this test completes, which it will do shortly, what's going to happen is I'm going to have a graph which looks a similar height, okay? They're not identical, okay, but they're kind of a similar level of activity. If you looked at these things, they would look pretty similar to most people. The only thing that's missing is the orange stuff, okay? So we've kind of taken away the commit weights, but how do we really know whether that's actually benefited anything? Because if we look at that top activity page, it kind of looks the same as the other one, right? It's not like any real benefit in that. So, well, there's a few ways you can look at this and a few ways you need to analyze this. I mean, the obvious thing to say is whether something's improved performance or not is that ultimately your users, your instrumentation, your metrics, your log files, your understanding of the system, you should have something which is measures whether this has improved performance or not, right? But then that kind of sounds like a little bit of a cop-out. So for example, what I mean by that is Swing Bench will show me that I've been able to hit 18,640 transactions per minute. Now, if I looked at the previous run, which I can't do now because of the way I've done the demo, the previous one would have showed a lower transactions per minute. It was something like 11,000 or something when I ran it previously when I was trying it out. So another monitoring tool could tell you that you've been able to process more workload. But when I raised this, because I did this demo all the time in the past, and somebody raised a really good point. It's like, well, I can see that I've made the commit stuff go away, but how's that help my system? You know, what's the relevance of this? I kind of know that it's probably not good that sessions are waiting on commits, but now they're just waiting on other stuff, right? Now they appear to be waiting on user I/O a little bit more. And you notice how the system I/O is diminished. And the system I/O is diminished because of the way we've configured the system, because the system I/O is where the log file parallel writes come from. And also because log write is less busy, that's why this is kind of about a session less than the previous activity. But still, I'm kind of saying all this stuff, and I kind of know what it means and all that kind of thing. But how do we actually know that this helped anything at all? All we've got is like a different pretty picture, which has made one of those horrible weight classes go away, and it's kind of like, yeah, we know that's good because we know Oracle, but it doesn't really tell us anything about the benefit of this potentially. So when I raised this question with some of the guys at Oracle, a guy called Graham Wood, who quite a few of you I'm sure have heard of, who worked a lot on, well, he's a long-term Oracle performance architect who works for Oracle and worked on a lot of this ASH data, ADDM, AWR, all these kind of things, right? So Graham knows this stuff. But fundamentally, he said a sentence which stuck with me for a long time and is worthwhile for you to think about. And when I said this, he was like, well, that's why the top activity page isn't the performance homepage. Because what tends to happen in demonstrations, and I'm as guilty of it as much as anybody else, is because top activity is such a fantastic page, I tend to never show people the performance homepage enough. So what's great about the top activity page, right? It's based on ASH data. It gives us the high-level overview, but because it's based on ASH data, it allows me to drill through all the different dimensions and stuff, right? It's session-specific, which is fantastic. It's SQL statement-specific. I can drill down to information at the right scope for the right kind of problem. The performance page doesn't do that, right? But it does have its own strengths. So it's not a page I use as often, but it has strengths which the top activity page doesn't. So for example, when we're looking at this overloaded system, I can see like there's too many runnable processes for this number of CPUs. It also shows the CPU weight effectively. And the performance pages measure it as using different data which is gathered in a different way. So what I'll tend to do, whenever I see an unusual thing in top activity I don't understand, I'll actually use both pages in tandem. It's just when I'm doing demonstrations that I tend to focus on this page a little bit too much. So one of the things that the performance homepage has down the bottom, and it's not going to show this very well now, is it? Damn it. My demo hasn't worked as well as I thought it was going to. Let me just go and check something here. 4:15. Okay, it's not working as well as it did when I tried it earlier. Damn it. I don't know why this has happened. This could be because things are overheating, right? But what I would expect, I apologize that it's not showing what I would expect to be able to show you. But what normally happens when I do this demonstration is that in this throughput graph down here, we have instance throughput per second. And along here is transactions. Now, normally when you run this test, and I'm still not quite sure why, but I suspect it is because the laptop itself is slowing down, is this graph would show a higher number of transactions per second than the previous graph. So although not only has the activity profile changed, but when I go and look at the performance homepage, I should see more transactions per second being fed through here. The fact that we're not seeing that, I suspect it's just because the system's getting a bit slower. So I apologize that isn't showing things the way that I hoped that it would. And it did earlier when I tested this extensively. Another thing to bear in mind is that the reason that this graph doesn't illustrate as well as we would like that there's been a performance improvement is because this particular benchmark that I've run is time limited. So I ran it for 2 minutes deliberately in both cases. Now if I'd made it workload limited, so if I'd said I wanted to process this number of orders, this number of transactions essentially, then the second run, because it did process more transactions, believe me, you're just going to have to trust me on this. In this particular case, although I have a ball post which shows this too. If this hadn't been time limited but had been workload limited, then this this bump in the graph, if you like, would have been narrower because it would have taken less time. So if you're actually comparing similar workloads and looking at the top activity page, don't get me wrong, the second run would have been narrower because it processes the same stuff more quickly. The problem is here is I'm processing for the same amount of time, but the actual workload's changed. And it's like, it can be a bit tricky to tell that kind of stuff, unless you look at the performance page when it's doing what I expect it to do, he said through the corner of his mouth angrily. Right, okay. So you see the load average is higher here. So I suspect that more stuff is actually running as a part of this. So the system's actually slower. There's more CPU weight here as well, right? And this is also probably why the I/O stuff's gone up, because as I said, when you have overloaded CPU and that fan that's making that noise at me, wait times are inflated as well as the kind of CPU measurements. But hopefully the important thing you understand is that when you're looking at time-limited benchmarks in particular, or you want to see what's happened over a period of time, then you should always cross-refer with the performance homepage, because there's several things now that it gave us that top activity didn't, right? One was the load average, one was the CPU weight, and one should have been that this throughput graph was higher. And of course you get other stuff like the amount of I/O that's feeding through the system, and it's broken down by I/O type. So there's lots of useful and important information on the performance homepage as well. It's just not based on ASH data, it's kind of based on measured data. That might take a little while to come back actually, given how hot my system sounds. So in terms of whether something has improved the system performance, going from the high level down to lower level, ultimately because you measure these things properly yourselves, right? Using whatever tools that you have, using instrumentation, using log tables. I mean, to be ridiculous, your users will tell you whether the performance is improved, right? But in kind of throughput situations, you'll have log files and tables, or you'll measure these things, hopefully. However, even if you don't have that kind of thing, there's performance metrics on the the performance homepage, which kind of show you how much I/O you're able to do, what your throughput was over a period of time, and that kind of thing. Okay. Right, let's pop back to this thing here. We're running a little short of time, so I'll probably just deal with one of these. How does Oracle work and how does it evolve? Oh, excuse me. So for this one, I'm going to show you this blog post again, which I showed you before. Now, one of the weird things about this is if I flick back up to the blog post, let me just see. This is based on a 8 concurrent session run of the Swingbench SH application, right? Now, as I say, I taught lots of courses on kind of the performance pages. I've done lots of conference presentations. And the SH application was always known to me as a CPU-intensive benchmark, right? So SOE and the call and suckle application were good for kind of looking at I/O and commit and log file sync issues, but SH was really good for overloading the CPU, and that's why I was using it here. So one of the things I want to get across to you here is how useful. Let's go back to here, and I'll run an SH benchmark. This could be another mistake, but let's see how we go here. Okay, so let's load the SH benchmark. Now, I'm going to run 8 users with 0 think time, and I'm only going to do it for a couple of minutes because it's really going to hammer the system. Okay. Now, as I say, in the past, when I run this particular benchmark, it was just CPU intensive. It was a great way of overloading my system. I just picked a number of sessions which was going to be bigger than the number of CPUs I had, and it would screw up the CPU consumption really quickly. Okay. So I'll switch the top activity page back to 15-second refresh. Yeah. I had a feeling it might overload the system, but I did want to show you a similar thing to the blog post in case you look up the blog post. And let me see whether this one's doing any better. Try refreshing the performance page. Well, the top activity page is refreshing. Fortunately, in the absolute worst case, the pain will go in a couple of minutes. Well, less than 2 minutes now. So what the SH benchmark does is, and it's one of the things I really like about Swingbench and also about the Oracle supplied schemas, is that I think it was in the 9i time frame, Oracle replaced the basic Scott emp and depth schema. Sorry, it didn't replace, augmented that schema with other schemas which used more features which are really useful for demos. So the sales history schema uses more warehousing features like partitioning and that kind of thing. So because it's a default supplied schema, it's really handy to kind of test things on and demo things on because other people are able to run the same test because Oracle databases have an SH schema these days. They just do. Okay, let's see how this boy's going. Okay, so I'm running 8 sessions. I'll switch back to the manual thing to kind of fix those refresh problems, which I bet it does. And pretty soon the benchmark will be over, in any case, and so things will calm down. Now, hopefully, and immediately, and here's the thing about the OEM performance pages, I kind of worry that people kind of think it's kind of Mickey Mouse and cowboyish and, Doug, it's just a bunch of colors and stuff. But particularly if you know what you're doing, it kind of lets you understand new problems incredibly quickly. So the first time I ran this SH benchmark, it took me like literally 5 seconds to go, what the hell is going on here? Because all of a sudden it's not consuming CPU, right? It's consuming lots of user I/O, right? That's the activity that's going on here. And I'm not sure, given my bunch of scripts or tracing things or proactively going out and looking at these things, I would have noticed this nearly so quickly. But literally, the first time I ran this, I'm like, hold on, what the hell's going on here? So if I go and look at this user I/O weight class, I'm sorry, I know we're getting near to the end, but I'm nearly done. If we go and look at this user I/O weight class, it's because this thing It's doing direct path reads, read by other session, DB file sequential read, DB file parallel read, DB file scattered read. And the difference here is that it's because 11G for serial processes, right? So these aren't parallel queries running, these are just serial processes. This is stuff which in the past, the old profile, let me see if I can dig that out for you, see if it's obvious from the image. I'm guessing it will be, right? Maybe not, maybe I've run it too many times. If this data is buffered, right, on previous releases of Oracle, it would just be reading stuff out the buffer cache, which would show up as CPU consumption. The first time I'd run it, there'd be some initial DB file scattered read, DB file sequential read, but once the stuff's in the buffer cache, it would just read it from there and it shows up as CPU, right, because they're just logical reads. However, in 11G, you have serial direct path reads, and Oracle decides whether it's more efficient for a serial process to do a direct path read and read it into its own PGA than it is to be doing buffer cache reads. And so that's what happened. And essentially, it's doing direct path reads now. There's also read by other session, because I've got 4 of these running. You get DB file parallel read, which again is because there's more than one session trying to do the direct path read thing. And we get a tiny bit of DB file scattered read, but barely anything, okay? Oh, actually, is that? No, that's over here. So when I highlight DB file scattered read, you should see this peak highlighting here. In this particular area, direct path read, read by other session, tiny bit of DB file sequential read, and some DB file parallel read. So what I really wanted to show you by showing you this was, from somebody who kind of has worked with Oracle for a long time, right? This is really actually quite a technical issue, and it's with, actually, it encompasses a few things. One, I've worked with Oracle for a long time, and actually the knowledge I've had from working with Oracle for a long time allows me to understand this information well. So sure, the more experienced you are, the more you can interpret this information quickly. But also this thing which I've run for often, so I've run this benchmark lots of times. Do you not think that sounds a little bit like it's your system, right? You know your system really well. I know the SH benchmark really well. If it starts doing something completely different on an upgrade because Oracle have evolved how Oracle works, then the main thing is, look how quickly I can see, compared to something that I'm familiar with, just how easily it is for me to say, hold on, that ain't doing what it's doing, right? And then I can drill into what it's doing, and I can drill into an individual session, and I can see what that individual session's doing. And remember, because this is just based on ASH data, I can go and look at the raw data, and I can go and see the specific wait events this is waiting on. I mean, they're aggregated nicely up here, but I can see it's doing direct path reads against SH customers. And I can also see it's coming from a specific module, action, client, all this kind of thing. I don't know whether it's jet lag, the time on the clock, or just being about to collapse. That's meant to be funny, but it doesn't necessarily work on webinars. But I just think this stuff is amazing. The number of problems I've had where I've been working with really technical people, right? And they've got their scripts, and they've got their tools, and they've done this, and they're tracing this, and they're tracing that. And I pop into this screen because they're over at my desk and got a problem. And I kind of go in, and I'm like, well, what the hell's that? Why is it doing that? So, yes, there are complications, and you need to think about how you're using the data, and the more experienced you are, the better it works. That's the kind of stuff I was talking about up here, right? How do I differentiate between what's important and what isn't? All these kind of things. How do I know whether it's actually improved system performance? It needs to be used with care, but kind of used with care, it just really improves the kind of speed with which you can get through a lot of data which you would have had to wade through in the past, and at least know where to look at the most important areas, the top activity, what's the most important thing here. And then you can use the skills to, it doesn't mean I never trace a session anymore, it doesn't mean I never go and look at any application logs. This just gives me a quick way to get to the problem as it is right now, which is killing the business. And on that note, particularly because it's 16:58 UK time, London time, I think I'm kind of done, James, apart from maybe questions.
Hi, Doug. Thank you.
Is everybody there?
Yeah, absolutely. Thank you. That was really nice to follow on from the other sessions. there have been a couple of questions. As you can imagine, there isn't a huge amount because I think the great thing about this session is that you've gone over the main question that people asked in the other two sessions, but we do have two questions here which I'll put to you. If anybody does have anything that they would like Doug to expand on a little bit more from the topics that he's gone over today, or if you remember some of the session or some of the items he was talking about in the first two sessions, then now's your chance. Please enter these into the question panels. But we do have two questions here, which I'll put to you now, Doug. So the first question is from Dawit Solomon. Thank you. He's asking, running SQL Tuning Advisor requires table-level read access. Is there a way around to providing access so the development team can run Tuning Advisor without giving direct access to tables?
Being honest with you, SQL Tuning Advisor isn't a thing I use a lot.
Okay. Well, so
I don't know the direct answer to that question. But one of the things I was going to say, James, is because I've got the blog and because people have the email contact details, and because I know some really friendly and helpful people in the EM group, who really, thanks to them, because they help me a lot with a lot of this stuff. If there's something I don't know, then people can always drop you or I a mail, or I'll post a comment on the blog, and I'll try and follow up on it for them. But me personally, I don't use SQL Tuning Advisor a lot, so I don't know the answer to the question.
Good. Thank you, Doug. There's a question here from Todd Laubach. Thank you, Todd. He's asking, will baselines also help indicate improvement?
Yeah, I think it's a really good point. So talking about baselines and adaptive thresholds, I was very keen. I actually made a note to mention adaptive thresholds earlier. So we mean metric baselines in this case, not SQL plan management baselines, presumably anyway. So one of the things that I had very high hopes for, and I still think is a fantastic idea and discussed with people a lot, is that if you look at a lot of what I was saying was, how does your system suddenly change? It's like this is an unexpected thing for this system. And it's amazing how often that in human reality on client sites, I go into OEM, and what it really excels in, but let me be careful, what it excels in is you can drill down to sessions and SQL statements and do detailed analysis of ASH data, right? It's great at that. But what it's also great at, and what the top activity graph is great at, is this kind of like, what the hell's going on here? There's something really weird going on with our system. And underlying that assumption that it's used that way a lot, I mean, I work with guys and we all kind of will jump into a graph for a system we know and we kind of go, that's not right. We kind of know how this should look, right? So we know this doesn't look right. So smart guys at Oracle realizing this are kind of like, well, wouldn't it make more sense if we kind of monitored how it should look anyway, and we kind of have a baseline of how the system normally looks, then, and by the way, I'm not answering the question directly at the moment. I'm just talking about baselines because I think they're really important and they're just maybe not used enough out in the field. It would be really nice if what Oracle did, and it does, and it can do, and it's been able to do for a while, is kind of monitor for you how your system normally looks. And when your system looks unusual based on your history, then it starts sending alerts out. And I just think it's an amazing idea, and it's kind of trying to replicate what human beings, who remember can manage hundreds and thousands of databases these days, are kind of trying to do manually. So this is where the baseline thing comes from. So not so much for the questioner, but for other people. If we've got all this data, it's kind of like we kind of know what our baseline performance would normally look like. And if it suddenly goes off the scale and starts doing something different, then maybe Oracle could kind of recognize that for us and send us information. So that's what I mean by baselines. I think it's what the question means by baselines, is what's the baseline performance of the system. Now, the baseline consists of multiple metrics, and they're kind of cleverly chosen metrics which reflect real workload on the system which the business might care about. Not to the level of maybe the method R kind of click and print invoice level, but like the number of users who are using the system, kind of how many transactions we're pushing through, so for more like batch processes. So a baseline contains information about how those values looked over time. If you then start to exceed those values by thresholds which you define, then it's going to start sending you alerts. So to finally get back to the answer to the question, or my answer to the question anyway, yes, the stats in the baselines would absolutely show you that your performance had improved because they measure sensible stuff. Like, I'm trying to think of a few off the top of my head, but there's like dB time per second, which is kind of another way of expressing average active sessions, and there's kind of transactions per session, and redo size I think is another one, because that's good for OLTP activity. So yes, you would see the baseline figures reduce because you would see the workload reduce. It's a really good question, by the way, because instead of just looking at graphs and what are people waiting on, thresholds are more closely related, I would say, to the performance tone page, which is about what's coming through the system rather than what are individual sessions doing right now. So yeah, I agree. That would be reflected in baselines as well. It's a really good point.
Thank you, Doug.
I hope that was the question and I answered it.
Absolutely. Todd's just left a note here to say exactly. Thank you. So thank you, Doug.
Cool.
So there's only one other point here, and it's from Kabiri Nayak. He's asking about the PowerPoint. I think this webinar isn't really suited to a PowerPoint. It is being recorded. I'm not sure whether Doug will make the PowerPoint available, but there's quite a lot of live demonstration here, so I don't really think a PowerPoint is going to add
too much. You mean the two-slide PowerPoint?
Yeah, absolutely, yeah. So the video will be available on the Redgate website. I'm sure Doug will tweet and post a link on his blog as well. And everybody that's registered to this session, you'll get an email from me tomorrow. Look out for my tweet as well if you're not on email, and you'll be able to find where this video is. Okay, I'm just going to take the screen back. There are also a couple of notes in here, Doug. People are suggesting that you should probably go and get some sleep now as well.
Thank you.
But generally, the feedback's great. So thank you again, Doug, and thank you, obviously, everybody for coming to today's session. Contact details, if you Doug mentioned it a couple of times about his website. There's a huge amount of information on there, so I'd definitely recommend you check that out. That's oracledoug.com, and follow Doug on Twitter at oracledoug. My contact details there as always. Please check out the allthingsoracle.com blog and follow me on Twitter at allthingsoracle. If you want to get in touch with me directly, my email address is there as well. So I'd just like to finish off by thanking everybody for attending today's session and thanking Doug once again for presenting.
Cheers, James.